we will learn to solve the system of equation by the matrix method. Okay. Before that, we want to learn two terms. One is consistent, another is inconsistent. Consistent means if for matrix A, if the determinant is not equal to 0, then it is non-singular and it has got unique solution. Okay, unique solution. So the inconsistent says that a system of equation is called inconsistent when determinant A equal to 0 of matrix A. It can have many solutions or whatever it is. That we will discuss later. Okay. Now I solve the equation by the matrix method. I have given a small question, that is 2x plus 5y is equal to 1, 3x plus 2y is equal to 7. We have learned it by linear equation 2 variable in class 10. Now we are going to learn by matrix method. By matrix method, the above system can be written that is 2, 3, 5, 2 into x and into xy, that is equal to 1, 7, 1, 7. Okay. Let A is equal to 2, 5, 3, 2. B is equal to x is equal to x comma y, x y, and B is equal to 1 comma 7. 1 comma 7. 1 is 1 and 7. Sorry. Oh, there is no comma. 7. Here, just check. If I multiply these two, I get 2x plus 5y, yes, is equal to 1, and 3x plus 2y is equal to 7. Okay, so let A, we have written this format, and the system can be written AX is equal to B. First check, that is determinant of A is, we check determinant of A is, that is 2, 5, 3, 2, that is equal to 4 minus 15, that is equal to minus 11, not equal to 0. That means it is a singular or non-singular. It is a singular or non-singular. It is a singular or non-singular. That means implies A is a non-singular matrix. Non-singular matrix. Because its determinant not equal to 0. Okay, then I can write, that means implies inverse exists, A inverse exists, implies A inverse, I multiply with A inverse both the sides, x is equal to A inverse A inverse A is equal to A inverse B. Okay. So A inverse A is I, that is equal to I, I will not write, in unit matrix into x is equal to A inverse B. Now A inverse can be written, A inverse means what? A inverse is equal to A inverse is equal to 1 by determinant A by 1 by determinant A, and the transpose of the cofactor of this matrix, that is transpose is that this is 2, this is 5, 5 3s are minus 3, and this is 3, that is minus 5, and this is 2 again. This is transpose again, its transpose means rows are changed into column. 1 by 11 is equal to 1 by 11 is equal to what? 1 by 11 is equal to, that is 2 minus 5 minus 3 and 2. Done? Okay. Then A inverse B. A inverse B is equal to then A inverse B, I will just find out. I am continuing from here, then x is equal to A inverse B, A inverse B, that is equal to A inverse is what? Minus 1 by 11, and this is how much? That is 2 minus 5, 2 minus 5 minus 3, 2. That is A inverse, and B is what? B is 7. Where is that B? B is here. B 1 7. B is 1 7. Okay. So I multiply now. That is equal to minus 1 by 11. I multiply to 1 by 7. Every time I am making a mistake. Please, this is 1. Matrix is never 1 by 7. That is 2 ones are 2, 5 sevens are minus 35. 2 ones are 2, 5 sevens are minus 35. The next step is that minus 3 and 14, class of 14. That is equal to 1 by minus 11 is minus 33, and class of 11. Therefore, xy is equal to minus 3, plus 3, this is plus 3 and minus 1. Plus 3 and minus 1. Answer is x is equal to plus 3 and y is equal to minus 1. Okay. So here ends the sum. Now here I have to write it is non-singular matrix, and non-singular means it is a unique solution. Unique solution means that is only one solution, that is x is equal to 3 and y is equal to minus 1. Let me see I have done it is correctly or not. This is minus 3, no, sorry, 3 2s are 6 and minus 1, that is minus 5, that is 1. My answer is correct. Okay, so I have done, it is over. Question number 2, the second question, I am repeating the non-singular matrix. I try to repeat. Non-singular, how can you find out? You can find out the determinant A, where matrix A is given. Determinant A is equal to, not equal to 0. Okay. Now, let the above solution says, the above system can be written above system can be written five, 7, 2, 3 into x comma y, xy, and this is 4, 3. This is the matrix method, where A is equal to 5, 2, 7, 3. B is equal to x is equal to x comma y, xy. I am always saying comma, and you can tell me this is wrong. And B is equal to 4, 3. This is the column matrix. Now, B. Therefore, we can write AX is equal to B. Okay? Now, determinant A is equal to determinant 5, 2, 7, 3. That is equal to 5 3s are 15 minus 14. that is equal to 1 not equal to 0 implies matrix A is singular, non-singular. Non-singular means how many solution? Implies unique solution. Therefore, I multiply with A inverse both the sides. Therefore, A inverse AX is equal to A inverse B implies X is equal to A inverse B. Non-singular. Here one thing I have to write, that is unique solution and A inverse exists. A inverse implies here A inverse exists. Why I have told you that A inverse exists? Because I can divide by A inverse. I can divide by A inverse exists. Implies X is equal to, that is XY implies, that is A inverse is that 1 by 1 here, that is adjoint of A. Adjoint of A, it will be 3 minus 7 and minus 2 and 5, that is transpose. I transpose it, that is equal to adverse this, and B is that, B is what? B is 4, 3. That is equal to, here it is, transpose is that 3 minus 7 and minus 2, 5 into the other matrix is 4, 3. Yes, 4, 3, yes. This is 4, 3. Acha, I multiply. That is 3 4s are 12. Any mistake here? Yeah. That is, this is 2, 3. This is 5, sorry. This is 5. This is 5. And here it is 5. Okay, done. So here 3 3s are this is 3 4s are 12 and 5 2s are 10 minus, that is equal to 12 minus 10, and here it is minus 28 plus of 25, minus 28 plus of 25, that is equal to 2 and minus 3. That is equal to, that is x is equal to 2 implies x is equal to, unique solution implies x is equal to 2 and y is equal to minus 3. Just let us check whether we have done it or correct or not. It is 2, 5 2s are 10, minus 3 is 6, yeah, 4, done. Mine is okay, fine.